ಸೊ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇವತ್ತು ಇನ್ನೊಂದು ಚಾಪ್ಟರ್ನ ನಾವು ಓದೋಣ. ಸೊ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂತೇಳಿ. ಸೊ ಆ್ಯಕ್ಚುಲಿ ಇದು ಬಯೋಕೆಮಿಸ್ಟ್ರಿಗೆ ರಿಲೇಟೆಡ್ ಆಗಿರುವಂಥ ಚಾಪ್ಟ್ರು. ಸೊ ಸ್ಪೆಸಿಫಿಕ್ ಆಗಿ ನೀಟ್ ಎಕ್ಸಾಮಿನೇಷನ್ಗೆ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ಕು. ಸೊ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂದರೆ ಗೊತ್ತಿದೆ ನಿಮಗೆ. ಸೊ ವಿ ಹ್ಯಾವ್ ಸೋ ಮೆನಿ ಕ್ಲಾಸಿಫಿಕೇಶನ್ಸ್ ಇನ್ ದ biomolecules. So among them carbohydrates, amino acids, proteins, vitamins, enzymes, hormones, nucleic acids, all these comes under biomolecules. If you go through with the carbohydrates, so their classification is very important. So all the carbohydrates are majorly classified into three types: monosaccharides, oligosaccharides, and polysaccharides. So in case of monosaccharides, we have glucose, galactose, fructose. So these are the examples for monosaccharides. Similarly, for disaccharides, we have sucrose, lactose, and maltose. So in case of polysaccharides, we have starch, cellulose, and glycogen. Like that, we have variety of carbohydrates. So after that, we have elucidation of structure of glucose. How the structure of glucose is conformed. So what is the structure of the glucose? So I told you so many times in our classes that in case of biomolecules, so we are not focusing on the biochemical functioning of the living molecules, but we are focusing on their structure, especially for structures. Similarly, here in case of elucidation of structure of glucose, we have so many points. So the first point here is molecular formula. We know that molecular formula of glucose is C6H12O6, and the next point here is parent carbon chain. Actually, so if you want to find the structure of a glucose, first we have to go through with the word root, and then we have to go through with the functional group and the prefixes. So while writing IUPAC name of an organic compound also, we are making use of same pattern. So first we are going to select the main chain present in the carbon atoms present in the main chain. After that, we are looking for suffix, that is a functional group, and after that we are looking for prefixes, that is branches or substituents. So here also we are going to find the presence of so actually the molecular formula of glucose is C6H12O6. So in this 6 carbons are there, 12 hydrogens are there, and 6 oxygens are there. How these 6 carbon atoms are arranged in the glucose, that is we are going to confirm by using the parent carbon chain, by treating the glucose with the red phosphorus in hydrogen iodide. So that is a reducing agent. It gives a N-hexane. So formation of N-hexane refers that all the 6 carbon atoms are present in a normal chain, that is no branches are there in the glucose. And after that, functional group. So functional group can be identified using by the definition of carbohydrates itself says that so it's a polyhydroxy derivatives of aldehydes and ketones. It may be either aldehyde or it may be a ketone. So functional group can be identified using that means a carbonyl carbon should be present in the glucose. So that carbonyl carbon is aldehyde group. So that can be identified by using that Tollens reagent, and also by using that addition and condensation reactions of glucose with hydroxylamine and HCN. So we came to know that this glucose containing aldehyde functional group. So and that aldehyde functional group is conformed by using that nitric acid. So if you make use of bromine in water is a oxidizing agent. So if you add that to aldehyde containing glucose, so that aldehyde is oxidized to carboxylic acid, giving gluconic acid. So that indicates the presence of aldehyde group in the glucose. Similarly, apart from that aldehyde functional group, still we have OH groups in the glucose. So here we have 5 OH groups, and that 5 OH groups is confirmed by treating glucose with acetic anhydride. Acylation of the glucose gives a glucose pentacetate. That penta indicates 5 OH groups are present in the glucose molecule. So and after that, among those 5 OH groups, one should be a primary OH group, and that presence of primary OH group can be again confirmed by oxidation of glucose. So that oxidation of glucose by using concentrated nitric acid. Concentrated nitric acid is one of the oxidizing agent. So in case of that alcohol, phenol and ethers, I told you that primary alcohol group upon strong oxidation it gives carboxylic acids, not for aldehydes. That means in case of alcohol, sorry, in case of glucose, among 5 OH groups, one should be primary OH group. And finally, using these points, we can write the Fischer structure of the glucose, and that Fischer structure is gets a drawback, so that cannot confirms the why this glucose can react with hydrogen cyanide, that is HCN, but glucose cannot react with the sodium bisulfite. It cannot show addition reaction with the sodium bisulfite. So that cannot be explained by the Fischer structure, and Fischer structure gets failed. So after that we have one more structure called Bayer structure. In that Bayer structure we have a cyclic ring structures with the 5-membered and 6-membered rings. 5-membered ring is called furanose, 6-membered ring is called pyranose. So after that we are going to write the Haber structure. Haber structure is very important for you. So while writing the Haber structure, we are writing the cyclic structure of the glucose. So in the first carbon, that is epimer, so if alpha, if you written that alpha, if it indicates OH group is on the right side. So if you write capital D, so that indicates in the 4th carbon OH group is on the right side. So while studying in the PU classes itself, we practice more regarding the Haber structure of carbohydrates, that is glucose, fructose, galactose, maltose, lactose, sucrose, cellulose, starch. All these Haber structures already we written, although we practice in case of that PU itself. So here one of the important point is glycosidic linkages. So these glycosidic linkages are the linkages so in which two monosaccharides are linked together. So that linkage is nothing but through 2 monosaccharides are linked together through oxygen atom. That indicates the glycosidic linkage. So here in case of competitive examination, they will ask some questions regarding the glycosidic link. What type of glycosidic linkages are there in the sucrose? What type of glycosidic linkages are there in the cellulose, like that? So they will ask questions here. So regarding glycosidic linkage, so you have to concentrate more here. So after that this concludes the carbohydrates part, and next we have amino acids. Amino acids are nothing but the organic compounds which containing both amine NH2 and carboxyl group COOH group. And here we have classification. Amino acids are classified into so many classes: natural, so acidic amino acid, basic amino acid, neutral amino acid. Generally we call these are alpha amino acids, because to the alpha, the general formula of amino acid is RCHNH2 COOH. So here 2 types of functional groups are there. One is amine functional group, basic in nature. Another one is carboxyl functional group, that is acidic in nature. Between these two, carboxylic group is the principal functional group, and we have to consider this is the main functional group. The COOH attached carbon is called alpha carbon. To the alpha carbon, NH2 is attached. So that's why we call it as alpha amino acid. Alpha amino acids. We have 20 naturally occurring alpha amino acid, alanine, glycine. So like that, I given some list of those alpha amino acids also in your PU classes. So after that, we have one more important point here called. So apart from that, one more important classification is there based on the biological importance. Amino acids are classified into 2 classes: essential and non-essential. So we have to go through with those essential and non-essential also with their examples. So isoelectric point is one of the very important here. So if you treat this amino acid in case of basic medium, it forms negative ion. In case of acidic medium, it forms a positive ion. So here it indicates that so it has both positive and negative ends. But at the isoelectric point where amino acid does not migrate towards either cathode or anode, because so the at isoelectric point amino acid is existed in present in form of dipolar ion. That means carboxyl groups donates H plus, forming COO minus. Similarly, amine group here nitrogen carrying one lone pair. So that using that lone pair, H plus will be added to the nitrogen, forming plus charge. So because of presence of positive and negative end, so we call it as a dipolar ion, and this dipolar ion existed at isoelectric point is called Zwitter ion. So many times asked in the competitive examination, what is the general formula of the Zwitter ion? RCH NH3 plus NH3 plus and COO minus. So this is the general formula of the Zwitter ion. So what is Zwitter ion? It's a dipolar ion existed at which point? Isoelectric point. So for different amino acids, different isoelectric points are there. The pH at which amino acid does not migrate towards either cathode or anode. This point is called isoelectric point. So after that we have proteins. Using these amino acids are linked together through a peptide linkage. So if you take one amino acid RCH NH2 COOH, so one more amino acid CH, this is NH. So then we have RCOOH. So this is also an amino acid RCH NH2 COOH. So here these two are condensation reaction, you know that. So two simple units are condensed together by the elimination of a simple molecules like water, sulfur dioxide, carbon dioxide, like that. Here water will be eliminated. So in that OH is liberated or eliminated from the carboxyl group, and hydrogen will be eliminated from the nitrogen group. So after that you will be getting a C double bond ONH. So the C double bond ONH group is called peptide linkage. So because of this formation of peptide linkage, so many alpha amino acids are linked together, giving a sequence of amino acid. So that polymeric chain, unbranched polymeric chain of that alpha amino acids are called proteins. So these proteins are again classified into two types, globular and fibrous protein. So and then we have a structure of proteins here. We have to study the structure of a protein, we have four different steps: primary, secondary, tertiary and quaternary. So we know the applications of these primary, secondary, tertiary and quaternary. Also primary indicates the sequence of amino acid, secondary indicates the presence of hydrogen bonding, tertiary indicates this alpha helix and beta pleated are linked together, and in case of quaternary structure of proteins, we are going to identify the extra linkages present in the protein, that is disulfide linkage, like that. So finally, so these proteins upon changing the temperature or pH or by boiling, so these proteins gets denaturated. So that is what we called as denaturation of protein. By changing the pH or temperature or any changes that can change the partial structure of the protein, so that can damage the structure of a protein and protein gets denaturated. So in case of denaturation of protein, only tertiary and secondary part or tertiary or secondary structure of proteins gets collapsed, whereas primary structure remains in contact. So that means the primary structure remains as it is. So while in case while secondary and tertiary structure of the proteins gets destroyed. So that is what denaturation. Example for denaturation is boiling of egg white, or you can say like this, curdling of milk using bacteria. So that is what examples of denaturation of protein. So after that we have vitamins. So vitamins are also nothing but the very important biomolecules which required in a small quantity, so which is responsible for normal growth and development of the living organisms. So these vitamins are also classified into two types: water soluble and water insoluble. Water soluble vitamins are examples: vitamin C, vitamin B12, so vitamin B1. So these are the examples for water soluble vitamins. These water soluble vitamins are not stored in our body, they can be excreted through the urine, whereas water insoluble is fat soluble vitamins like vitamin A, D, E, K. So these are the fat soluble vitamins. These vitamins are stored in our body, in our liver adipose tissues. So this is about vitamins. So and we have deficiency, and what are the diseases caused by the deficiency of the vitamin. So if you the vitamin deficiency of vitamin A is there, means it forms a night blindness. So if vitamin B is there means beriberi, C means scurvy, D means rickets. So like that, if deficiency of vitamin K is there, so it reduces the it increases the blood clotting time. So similarly, we have different deficiency of vitamin can cause different diseases. I think you are very familiar with the biology subject. So if you go through with that, you can get a list of that vitamins and their deficiencies and their applications. And next is hormones. Hormones are also very important biomolecules. They are responsible for our actions. So they are responsible for our normal conditions. So these are biochemical. Hormones are also known as biochemical messengers. So oxytocin, thiamine, thyroxine. Thyroxine is an example of iodine containing hormone. So very important is there here. And insulin is also an hormone which regulates our blood sugar level. So these are secreted in our endocrine glands like pituitary glands. So like that. So next is enzymes. Enzymes are also very important biochemical catalysts. See, hormones are biochemical messengers, but enzymes are biochemical catalysts. They helps to catalyze a specific biochemical reaction. So here enzymes are highly specific in nature. They require a moderated or optimum temperature. So that is at 37 degrees centigrade. So an enzyme can work more efficiently. So we have so many examples for enzymes: zymase, maltase, diastase, invertase. So these are a few and your lactobacilli. Lactobacilli is an enzyme which converts milk into a curd. So like that we have so many enzymes, and you should go through with those examples also. So next is nucleic acids, and this I think this nucleic, you are very familiar with nucleic acids in biology, that is genetics chapter. Here we have DNA and RNA. So what are nucleic acids? These are present present in the chromosome. The protein part of the chromosome is nothing but nucleic acids. And there are two types of nucleic acids are there. One is DNA, another one is RNA. So deoxyribose nucleic acid, ribose nucleic acid. So if you divide this, nucleic acid is a polymeric chain. So the monomer unit present in the nucleic acid is nucleotide. Nucleotide is the monomeric unit present in the nucleic acid. So these nucleotides, upon polymerization, you will be getting a nucleic acid. So if you divide this nucleic acid into simple units, you will be getting a nucleotide. So this nucleotide, again dividing, it gives a nucleoside plus phosphate group. So nucleoside, upon dividing, you will be getting pentose sugar and nitrogen base. Using this dividing, we came to know that there are three important parts present in the nucleic acid. One is pentose sugar, another one is nitrogen base, another one is phosphate group. So this pentose sugar and nitrogen base together we call as nucleoside. To this nucleoside, if phosphate is attached, we call it as nucleotide. So these nucleotides, upon polymerization, you will be getting a nucleic acid. So here in RNA, sorry, in case of DNA, the nitrogen base present in case of DNA is AGCT, that is adenine, guanine, cytosine and thymine. In case of RNA, we have AGCU, adenine, guanine, cytosine and uracil. Nitrogen bases present in pentose sugar present in DNA is beta deoxyribose, whereas in RNA is beta ribose. That is the pentose sugar moiety present in the DNA and RNA. So finally, we have differences between DNA and RNA. The main important biological importance of DNA and RNA is DNA is used to store the genetic information, whereas RNA is used to synthesize the protein. So these are few points I am going to give regarding the biomolecules. If you go through with various textbooks, various synopses, you may get plenty of information regarding the biomolecules. So let me see some questions now. So first question here is, on oxidation with nitric acid, glucose as well as gluconic acid both yields. That means glucose and gluconic acid both are oxidized with nitric acid. The partial structure of glucose is CHOH taken 4 times CH2OH. So this upon treating with the concentrated nitric acid, so this concentrated nitric acid acts as a strong oxidizing agent. So it oxidizes both aldehyde into carboxyl and primary alcohol into carboxyl, giving COOH. So CHOH taken 4 times, so COOH. So this is what saccharic acid. Saccharic acid. So gluconic acid also reacts with nitric acid. Gluconic acid formula is COOH, CHOH taken 4 times, so CH2OH. So aldehyde group is oxidized to COOH. This is gluconic acid. So this gluconic acid also reacting with nitric acid. So it also gives saccharic acid. That means both glucose as well as gluconic acid both reacts with concentrated nitric acid. Both are yielding a product called saccharic acid. Hence in the given option, so the right answer here is option C, saccharic acid. So the second question here is, so the pentaacetate of glucose, you know glucose pentaacetate, CHO, actually OH will be there. So OH taken 4 times. So this H is acylated. It is replaced by COCH3, getting COCH3 taken 4 times. CH2O. So this H also replaced by acyl group, that is COCH3. This is glucose pentaacetate. So this glucose pentaacetate containing one aldehyde group. So this aldehyde group does not reacting with the hydroxylamine. We know that. So any carbonyl compound so reacts with hydroxylamine. So it undergo addition followed by elimination, that is condensation reaction. Already we studied in the aldehydes, ketones and carboxylic chapter itself. That is O from here and 2 hydrogen from here. So is eliminated to give. So C double bond N OH. So giving oximes. But this reaction is not taking place in case of glucose pentaacetate, even though it contains aldehyde group, because so this in case of glucose pentaacetate, that aldehyde group, that is C double bond O group, is not free. It is involved in the ring formation. I told you Fischer structure gets failed because why that glucose or fructose or galactose does not reacting with the hydroxylamine is not explained by using Fischer structure. That's why it gets failed, and we came to the one more structure called Bayer structure, where where the cyclic members or cyclic rings are present. So that's why here is asking that why that glucose pentaacetate does not reacting with the hydroxyl amine group, because in case of glucose the aldehyde group whatever present here is not free. So that's why the right answer here is option D, absence of free CHO group. So next question is, the two functional group present in the carbohydrates are. So the definition of carbohydrates itself indicates that, so these are the polyhydroxy. Polyhydroxy means more OH groups are there. Polyhydroxy derivatives of aldehydes and ketones. Either aldehyde group will be there or ketone group will be there. So that's why carbonyl carbon is compulsory present in the carbohydrates, and OH group is also present in the carbohydrates. In the given option, in the actually so many students chooses this option D, OH and CHO. This is not the right answer here. So C double bond O and OH is the right answer, because if you write C double bond O, it may be either aldehyde or it may be a ketone. So that's why the two functional group present in the carbohydrate is both carbonyl group as well as OH group. So the carbonyl group may be either aldehyde. If it is aldehyde, we call that carbohydrate as aldoses. If that carbonyl group is ketone group, we call it as ketoses. So the C double bond O and OH is the right answer here. So in the next question, so the disaccharide present in the milk. So milk containing a disaccharide, so that is a lactose. So which disaccharide is present in the milk? That is lactose. Lactose is made up of a two monosaccharides units, and that monosaccharide units present in the lactose is beta galactose plus beta D glucose. So these two monosaccharides are linked together through a C1 and C4 and C4 cross-linked glycosidic linkage. So you will be getting lactose. So hence, so the disaccharide present in the milk is lactose. So next question is example for denaturation of protein. I told you in the synopsis itself, by changing the temperature or pH. So secondary and tertiary structure of the protein gets destroyed. So that may leads to the denaturation of a protein. So here he is giving some examples. So coagulation of egg white on boiling, curdling of milk by bacteria, both A and B, none of these. If you go through with the option, so both A and B are the examples for denaturation of protein. Hence the correct answer here is option C, that is both A and B. So next question is the function of enzyme in the living system is to. I told you enzymes are the biochemical catalysts which are used to catalyze a specific biochemical reaction. So option A here is transport oxygen, that is not the right answer. Option B is providing immunity, that is also not right answer. So which catalyze the biochemical reaction, this is the correct answer. Hence option C is the correct answer for this question. So next is which of the following is a fat soluble vitamins. I told you vitamins are of two types. One is water soluble, one is fat soluble. Among the given, which is fat soluble? So both vitamin C and B1 are water soluble, but vitamin A is fat or oil soluble, which is stored in the adipose tissues. So option A is the right answer here. So in the next question, so nucleotides and nucleosides mainly differs by. I told you nucleic acids is a polymeric chain of nucleotide. Nucleotide divides into nucleoside and phosphate. Nucleoside divide into pentose sugar and nitrogen base. That means so nucleotide containing so both nitrogen base, pentose sugar and phosphate group, whereas nucleoside containing only pentose sugar and phosphate group. So the pentose sugar and nitrogen base. So that's why these two are differed by using presence of phosphate units in the nucleotide. So that means the correct option here is presence of phosphate units. So differs both nucleotide and nucleoside. So hence option A is the right answer. So next question is match the list 1 and list 2 from the given combinations. So in the list 1 they given some combination and we have to choose the correct answer in the list 2, correct matching part in the list 2. So in the first he given pepsin. So pepsin is an enzyme which is present in the stomach, which is responsible for digestion of our food. Hence pepsin is a digestive enzyme. So this pepsin matches with the option B, that is digestive enzyme. So second one here is nucleic acid. So nucleic acid is a protein part present in the chromosome. So it is of two types, DNA and RNA. Where is the very important importance of nucleic acid is it is a genetic material. Hence in the list 2 it matches with the option A. So third one is ascorbic acid. Ascorbic acid is a vitamin. So vitamin C. So that's why it matches with the option E in the list 2. So the fourth one here is testosterone. Testosterone is one of the male sex hormone. So hence it matches with the option D in the list 2. So if you see the combinations here, so A with the B and 1 with the B, 2 with the A, 3 with the E and 4 with the D. So hence here it is B, A, E and D. So B, A, E, D present in the option B. Hence option B is the right answers. So Finally, I want to tell you one thing. Biomolecules is very important and very easily you can solve the question here. So this is very important question. One question definitely arises in the NEET examination. So kindly follow all the points of biomolecules using various reference textbooks and solve so many questions. So some of the biological depth matters will be there here. So kindly go through with all the points. So thank you. I will meet you in the next chapter.